So this is number 42 in chapter 5. I've drawn the picture. We have a box on a ramp of angle theta and another hanging box, which we'll call the hanging box M1 and the box on the ramp M2. So what we're going to do is we're going to look at this system. Later on we'll draw the free body diagrams for each one, but if you look at this system, and they do tell us that M1 is going to be much bigger, M2G is much bigger, and so the direction of this object, it's going to go that direction, right? And again, there is no friction. No friction on this example. And so for this system, what we have is we have M2G sine theta, it's gravity's component, down the ramp, minus M1G equals M1 plus M2A. And again, if you think of the ramp, M2G has this component down, but it goes down the ramp and into the ramp. If this angle is theta, this is some alpha, which is the same as that angle, which means that angle is theta, which means this piece is mg sine theta, and that piece is mg cosine theta. Gravity is pulling it down the ramp and into the ramp, and so that's why I have m2g sine theta right here. M1G is just strictly hanging and it's totally opposing the motion, and then M1 and G together combine for the inertia of the system. And so when you've given those values, it looks like this is 6 kilograms and 2 kilograms with an angle of 55 degrees. At this point you can plug into this and get an acceleration of 3.57 meters per second squared. Okay. Now if we just look at M1, it's got M1G down and it's got some tension up. And if you think about the acceleration is in this direction, so that must mean the tension is greater than M1G. So T minus M1G equals M1A. And again, all I'm doing is F equals MA again. That's all I did up here. This was F equals MA. But now I know the acceleration. So based on that acceleration, then I can find the tension. So the tension should be 26.7 newtons because it's a force. And if I want to find the velocity, well, velocity just equals v naught plus at. The initial velocity was 0. And so the velocity, if you accelerate it 3.57 for 2 seconds, gives us our 7.41 meters per second. Okay? If you wanted to look at the free body diagram on M2 to find the tension, you would say that there's mg sine theta down the ramp, tension up the ramp, and it's that difference. So it'd be m2g sine theta minus the tension equals m2a, and you could have done that and you would have found the same tension.